Good morning, guys. So, I hope you understood the portions which were taken in the last video. Right, we talked about the free body diagrams in that video, right? And motions acting on it, force acting on it, how you will find the acceleration and tension if there is a string present. And the last section we stopped was pulley system, right? And I believe we found the acceleration value as m1 minus m2 divided by m1 plus m2 into g, and you found the tension between or tension on the string is 2m1 m2 divided by m1 plus m2 g, right? Clear? These two expression we found, right? Now we'll continue with the pulley system itself, right? But make sure, guys, after this I will tell you a small trick to do this type of questions, right? This type where the pulley is fixed, right? Clear? Pulley is fixed, that is, the pulley is not moving up and down, the pulley is fixed, right? Remember the figure was like this, right? And the pulley was fixed like this, right? Now we will have also learned if the pulley is not fixed later on. Okay, suppose there is the condition like this, right? There is mass m2 here, there is a block here, and there is a mass here, let's say m1, right? Clear? M2 is resting on the horizontal frictionless table. Here, no, we are not in any of the cases till now we have not considered friction, right? Clear? Right? So you know that m1 will be accelerating downwards in this direction, right? With the next a, right? If this is a, obviously this section also will be experiencing an acceleration a, right? And the downward force will be m1g, and there will be tension which is drawn upwards. The same string is forming the pulley, right? So here also the tension will be T, right? Now see, there is only external force acting on this mass, right? This m2 mass is not having any external force acted, tension not included in the external force section, okay, right? Because tension is the part of the string which is inbuilt in the system. The system consists these two masses and the string, right? So external force, that is the weight, this external force is acting on only one mass which is m1, right? Keep that in mind. So let's talk about first m1, right? Equation for it, that is, see, acceleration direction we take it as positive, right? So for acceleration, if it is positive, then m1g is in positive direction and tension is in negative direction, so hence minus t is equal to m1a, right? This is our first equation, right? Now m2 is moving horizontally only, there is no vertical movement, right? So I can write m2a is equal to tension, right? Clear? Or I can write it as, in order to write it beautifully, this is T is equal to m2a, right? Now let's add this is the second equation, and the first equation, please add it. So it will be what? m1g, tt cancels off, is equal to m1 plus m2 common term a, or I can write a is equal to m1 plus m2, sorry, this m1g, right? Sorry, m1g divided by m1 plus m2, right? Now you can substitute this value in here so that you will get tension is equal to m1 m2g whole divided by m1 plus m2, right? You got the equation for tension, you got the equation for acceleration. Now it is very difficult to mug up this type of equation, right? So in this case where the pulley is fixed, I'll tell you a small trick. So we'll start with the first one which we learned in the last video. There was a mass like this. Let's say there is another mass here, right? Let's say this is of 1 kilogram, this is 2 kilogram, right? So obviously there will be 1g downwards and here it will be 2g, right? Clear? And you would have drawn tension here, you would make equations, etc., right? Now I'll tell you a trick. Now to write acceleration, right? To write acceleration, it is very easy. What is actually acceleration equation? It is force by mass, right? Now here I will write net force by net mass. In the case, that is in the system, how much external force, net external force is acting, and how much m net or net mass is present. How many mass is present here? Okay, let's say, okay, I'm going to change, it's okay. We'll write it as how much mass is there? 2 plus 1, so 3, right? That much is easy. For net weight, if this is considered as a point, that is this point, right? So 1g in this direction and 2g in this direction, right? So for net force, right, higher value minus lower value, right? So you will get g by 3 as acceleration value. Very simple. You will get the same value with the equation, right? Clear? Right? Acceleration is net force divided by net mass, right? So net force means what is the net force which is at T we cannot consider because it is a part of the system, right? This 2g and 1g is exerted by an external force known as gravity, right? So I will write net force. Both of them are in the opposite direction with respect to pulley, right? So it becomes 2g minus 1g divided by 3. That is a trick for memory. Okay, right? Now the same scenario you can take here. See, in the same system they will see another type of question also. You have an additional mass here, say 1 kilogram again, which is connected to this 2 kilogram, right? Then again you can write again acceleration net 2 kilogram and 1 kilogram are in one side, so it will be 3g, right, minus 1g divided by net mass will be 1 plus 2 plus 1, that is 4, or 2g by 4, or can write g by 2 as the acceleration. G, obviously I am not writing the values, right? This is a way of doing, right? Multiple masses, if the masses here is connected, then also you can use the formula. This is not a formula, I'm just giving a trick, right? And today we started with another pulley system. We'll do that also with a weight value. Okay, this was a pulley, right? Let's say this is a mass and there is another mass. Let's say this is 5 kilogram and this is 1 kilogram, right? Now remember we used to write here 1g, right? And this will be accelerated downward because there is no vertical forces here. Vertical forces are only here, and there will be tension outside, tension outwards, right? If this downward acceleration, so this will be acceleration this here. Now this problem we have done with m1 m2 and we have found the equation also, right? Now I can write acceleration here, net force here, don't take the tension. What is the net force here? Only one net force is there, right? It is 1g divided by net mass is 5 plus 1, that is 6. Acceleration is equal to g by 6. Clear? Guys, you might be have understood how acceleration is found, but you guys might find how the tension has to be found. It is very easy. You found in this scenario that acceleration is g by 3, right? So we can utilize this system with 1 kilogram. There is 1 gram or 1g downwards, right? Tension upwards, and right, and acceleration is in upward direction. So which equation you will write? T minus 1g is equal to ma or 1a, right? So here is 1, so you just write it as a, right? You have found the value of a, which is g by 3, and there is t minus g here, or you can write t is equal to g plus g by 3, or it is 4g by 3, that is tension, right? Clear? It is very easy, right? Right. Rather than by hearting the equation, I would expect you guys can understand the logic of it, this one, right? This much is clear about the tension, right? Now the another section which is there in your textbook, or if you open your SM, is the motion of a body in a lift, right? That is, we have to take it in two conditions. Let's say, just like your material, we'll start with case 1, right? That is, if the body is at rest, or I can say the lift is at rest, right? Or we can say if it is moving with constant acceleration or velocity, right? Upward or downward direction. Not sorry. So before going to that one, if you don't understand the logic of writing the free body diagram, it is very difficult to move this chapter. Okay, so if you are having any doubt, please call me and clarify it. Okay, so the first condition, case 1, is lift is at rest, right? Or it is moving with constant velocity. If it is constant velocity, obviously the acceleration is 0. It can be moving up or down, right? Clear? Right. So that means the lift, let's take the lift is at rest, right? So this and all conditions we have to deal with, right? Now the acceleration is 0. Suppose this is lift and there is an object with mass m. So there will be mg downwards and there will be a reaction n upwards, right? Clear? There is no horizontal direction force. So I will write, since here acceleration is 0, right? You can write n is equal to mg. Simple, not at all twisted. Now let's move on to the next case. When the lift is moving up, that is case 2, lift moving up. Right, again I will take the same lift. We are having the same body, let's say. Right, so it will be exerting a very mg downwards weight. There is a normal reaction n, and the case is, sorry, the lift is moving up means it will be having a net acceleration in upward direction. Acceleration direction is positive, so at n minus mg is equal to ma, right? Or I can write n is equal to m comma or common g plus a, right? Or you can even write this form, just rearrange it as n is equal to m into a plus g, right? Clear? That is, see, what is the normal reaction? That is, suppose you are having a measuring gauge here to measure the weight of the weight, right? So that weight was initially showing how much. If the lift was at rest, that lift or that measuring device would have shown the weight of this person, right? The person or this mass is it is kept on a weighing machine, and we are saying the lift is at rest. So the n is the weight which will be there on the measuring device, hence it is known as apparent weight, right? Apparent weight, right? So when he measures his weight, he will feel that he is having the actual weight itself. That is, suppose he is 50 kilogram weight, so the reading will be also 50 kilogram itself. That is, apparent weight on the machine will be also 50 kilogram. I hope you understood this one. That is the first scenario, that is the weighing machine will be showing exact your weight itself. Whereas if the second scenario which we draw is when the lift is accelerated upwards, then we will see that on the weighing gauge where the person is standing, on which the person is standing, will show its value greater than his actual weight, right? That is, a person who is standing in a lift which is moving up will weigh more than a person who is standing in a stagnant lift or a resting lift. Okay, that is this n, this is actually known as apparent weight. Clear? And mg is our actual weight. Clear? Now we'll do the last scenario of the lift. If this is the object mg n, and let's say the lift is getting accelerated downwards. In this condition, again we can write the equation as what? Mg is positive in the same direction of a, minus n is equal to ma, or n is equal to mg minus ma. See, mg minus ma, right? So that means the apparent weight on the weight which is shown on the weighing gauge on which the person is standing will have lesser or will show lesser weight than the actual one, right? Clear? And there is a small case, or I can say case 4 also, that is when the lift is freely falling, right? That is, if the entire downward acceleration is equal to g itself. So obviously there is a mass like this, and this will be mg, right? So I will write mg minus n is equal to mg itself. So mg cancels out, or can say normal reaction will be equal to 0. That is, the weighing gauge on which the person stands will show the weight 0 when the lift is suddenly falling or freely falling. Clear? Right? Now, moving on. Now we are going to do some of the things or the questions which is not present in neither in your material, but it is a repeated type of NEET questions, right? So we require it in a higher level, right? So let's draw the picture for it, right? This is the surface, right? Let's say there is a fixed pulley here, right? And a string is drawn here, and there is a movable pulley. That is, this one is fixed. Let's say both are fixed. Let's say this both are fixed. That is better, right? And this is another mass. Let's say this is 2 kg, right? And let's say we are having a 5 kilogram weight here, right? This much only, right? Simple. And you are asked what is the acceleration of the system, right? Clear? Again, this is a fixed one, guys, so do not worry. We started with the fixed one with a complicated looking figure because we have to do this type of question itself with moving pulley, right? So how would you do? I told you, you have find the acceleration by net force by net mass, right? So net mass you can directly write it as 7, right? 5 plus 2. How would you write regarding the net force? How do you write? See, this 5 kilogram is on the ground, right? There is no vertical motion. There is no external force acting on it. External force is only on 2 kilogram, which is moving with an acceleration a downwards. So I can write, right, force in place of force. I can write 2g, right? 2g. That is a force. So you got the acceleration equation directly, or you can go by the roundabout way which I have taught. This will be having a tension outwards, right? This tension outwards, this tension outwards, right? So for this 5 kilogram, let's write t, right? So let's say this is moving with an acceleration downwards, means this 5 kilogram will be moving with an acceleration here, right, in this direction, right? So for 5 kilogram, right, this tension is in the direction of acceleration, so t is equal to ma, or in place here m, I am writing 5a. Like similarly, let's write for 2 kilogram also. Here acceleration and 2g is in the same direction, so I write 2g minus t is equal to 2a. Add these two equations, you will get 2g is equal to 7a, right? Or a is equal to 2g by 7, right? You got the same equation, right? And substitute the a value here. T will be equal to 5 into 2g by 7. You will get 10g by 7. See, so this is a one-step process, or this is also easy but takes time, which we don't have in our NEET examination. Clear? Right. See, guys, you have to learn this type of questions because many of the students, we have, for them, I didn't take the 11th class, I started by 12th. So those guys again asked me to teach this part because they have not been taught it, right? That's why I ask you guys to listen to the lecture properly and understand it. Okay, now now this is not the way of drawing, okay? I'm just making an easy way. In place here, I will not write 1 kilogram, I just write 1. Here I'll write 2. I hope you understood this kilogram, right? Right, this is A pulley and B pulley. Now here A pulley is fixed, right? It is fixed here. B pulley is free, right? or B pulley is movable. It is not fixed in any way, right? So when you are exerting force on it, it will be also rotating. That's the meaning of it. Okay, right? Clear? So that means if the pulley is movable, we cannot say that this or we cannot say that the acceleration of the system will be same, right? Remember the first all condition we didn't find the we found the common acceleration for m1, m2, etc., right? m1 and m2 are having some acceleration that cannot be taught or told about that in the similar way in this case, right? It is not the same scenario, and a lot of imagination is required while solving this type of problems, right? Clear? Right. So how can we solve? Suppose this B pulley which is movable, right? Remember, right? It is, suppose it has adjusted here and it has moved in a distance, that is by some motion. Let's say it is moving upwards, right? That is, let's say there is an x displacement of the pulley in upward direction, right? Right. So that is, this string will be having an upward motion or displacement by x. This pulley or this wire will be also having a displacement in x displacement in the upward direction. Remember, I am taking it again and again. This left string of B pulley, if it is moved by x distance, right? Similarly, if the right, if this is pulled, similarly I am telling you this part is also pulled, right? When does it occur? When the entire pulley moves up by x distance, right? If you want, I can repeat. So we'll start with this one. Let's say there is a pulley which is movable. Let's say this pulley moved by a distance or displacement of x, right? If pulley moved a displacement of x, then its left string as well as its right string will be also experiencing a displacement of x, right? Clear? Right. So if that means this entire system is having a 2x displacement, that is in play. If you listen about the string, only the string, obviously the pulley is having a displacement of x, but just understand that if this much part, if you are having this much portion, I will tell you another example. Rather than pulling up, let's say I am bringing B downwards. We brought B downwards by a distance x, right? So this strings also, then from where the string will be moving, the string will be moving from here, this side, and this comes down and the position changes here, right? So there will be an increase in x here, there will be an increase in x here, right? And there will be a reduction of 2x from here. Clear? That is, if you want to change the x value, I can just say, suppose B moves downward by 1 centimeter, right? Then this string in the left side will be also moving down in 1 centimeter, and the right part of the string will be also moving by 1 centimeter. If both of them are, that means that much loss of 2 centimeter is there from this side, Clear? Right? Similarly, the opposite condition, suppose a pulley is moving upwards by a distance x, then the left and the right side string will be having displacement of x and x, so that there will be a displacement of 2x in this string. Clear? Right? Clear? So that is, if by in which direction, suppose B is moving x distance in upward direction, x and x displacement will be in upward direction, but 2x displacement will be in downward direction. Clear? So very clear. Now I am going to draw the figure in complete section. Let's move this and all outside. I should rub now. Right, remove x. Concept is clear? Right. Now, okay. If there is a displacement x, the corresponding acceleration for it, if it is a, then for 2x displacement, the acceleration will be 2a. Common sense, right? Displacement, if it is x, then its acceleration is equivalent to a. If there is a displacement 2x, that is, the displacement has increased twice, so the acceleration also increases by twice, right? Don't think in a differential manner, guys. Just think in a common sense way. Clear? Right. Now let's say, now just initially going to take that for 2 kilogram, right? We have to draw the tension. Let's say this is tension, this will be 2G. Here there will be tension, there will be 2G. Sorry, 1G. Sorry for making mistake. And there will be tension. Now there are other two strings for these two pulleys, right? Right. So this is very difficult because I am not supposed to write T there, because see, this string is continued to here, right? So the tension here should be T, right? Now this string has continued to here, so this tension will be T, right? Now this vector form like this. This is T, this is T. So what will be this tension? This will be 2T. So this is 2T. T, 2T. Clear? Right? Now again we have to talk about acceleration. Now we told this is explained, the having acceleration, that is the pulley is having an acceleration for A, then the acceleration for this body will be 2A, right? Right? Now we'll think that like that way, right? Suppose this entire system of 2 kilogram is moving down by an acceleration 2A, right? So the pulley will be moving with A in upward direction. Similarly, this string will be having an acceleration upwards, right? Clear? Right? Right? Right. I'm sorry for the disturbance, okay? So let's write for 2 kilogram. You are hearing the disturbance, right? In the case of 2 kilogram here, what and all can be written? 2G minus T, right, is equal to 2A, right, into 2, mass into acceleration, right? Or I can write 2G minus T is equal to 4A, right? This is the first equation, right? Now let's write for 4 kilogram, sorry, 1 kilogram, that is for 1 kilogram. How can you write? It is, sorry, 2T upward, that is the acceleration, right? See, and you would have see if this is an entire system, right? Clear? If that is having an acceleration in this direction, so 1 kilogram will be also having an acceleration A. Clear? Because this entire system, if it is moving with x displacement, so this 1 kilogram will be also having x displacement only. Common sense, right? So in the case of 1 kilogram, I will write 2T minus G is equal to 1A, that is mass is 1, right? So you have two equations, solve these two equations, right? Clear? So how would you solve it? Here it is T now, so just multiply this one with 2, so you will get 4G minus 2T is equal to 8A, and there is 2T minus G equal to A. Then add these two guys, you will have 2T cancelling, 4G minus G is 3G is equal to 9A, or I can write here G is equal to 3A, or I can write A is equal to G by 3. Now that is the acceleration of which one? This is the acceleration of pulley, right? This is the acceleration of pulley as well as the acceleration of 1 kilogram weight. Acceleration is G by 3. Now what is the acceleration of 2 kilogram? You have told that it is 2G, so sorry, 2A. So it will be 2G by 3. Clear? Solved? Now this is a lengthier process, right? We require a simpler one, right? This A, etc, etc. So I will talk about a small concept. Suppose this is a pulley and there are two masses like this. Now guys, you will not get this type of concept in any books, okay? I'm just telling you. Oh, sorry. Let's say this block is coming down with the acceleration A, means obviously this will be A itself. Let's say we are going to take it as different values. This is A2, then this acceleration is A1, and let's say the pulley is movable. So obviously these, I told you, these two bodies will not be having same accelerations, right? Let's say the acceleration of pulley is equal to what? A. Then there is a small formula. A will be equal to A1 plus A2 by 2. Now signs should be taken. Okay. A is equal to A1 plus A2 by 2. Now in this scenario, minus A, right? No, sorry, minus L. This A is positive. Why? Because it is upward direction. A1 is also positive, but A2 is downward, so it is supposed to be written as minus A2 by 2. So by heart this equation, then you just give signs for these conditions. Clear? Right? Now let's move on to the just previous question we did now. This one will do with this concept. See, then you will ask me, why are you taking a lot of lengthier questions? You could have just tell the equations, but I don't think that is the correct way of teaching. Right? You have to be clear about the concept. Right? Let's say this was fixed now. Two, one. Let me write 1 kilogram. 1. Right? Now, let's only talk about pulley in the first condition. This pulley is just like the previous our system, right? Now there are two acceleration right here. See, we'll say take these two as the bodies, that is these two strings. Remember this system, this and this are these two legs, this one and this one are these two legs, and this is the pulley reverse condition, right? Clear? Now remember, in this darkened pulley, the one which has been darked, you know this weight is moving downwards, right? Clear? Right. Now let's say if this is moving with an acceleration, let's say if it is moving with downward with acceleration A, so there will be acceleration A here also, string common, which on the concept which we have learned earlier, because this is fixed pulley, okay, not a movable pulley. So this is string and this string acts as a system. Clear? I have to rub this off. Okay, so here also our acceleration is A. Now what is the acceleration here? This one, it's a fixed end, right? So there the acceleration will be 0. Okay, right? So let's say AP is the acceleration of the pulley here. So acceleration of pulley is A1, let's say it is A, plus A2, that is 0 whole divided by 2, or acceleration of pulley is A by 2. That is, if the 2 kilogram weight is moving downwards with acceleration A, then the pulley will be moving with half of its acceleration. Or let's say if this is 2A, that is, if 2 kilogram is moving down with an acceleration 2A, so acceleration of the pulley will be 2A by 2, that is A. Right? Now you got the straight away answer. Initially we had to find the displacement, etc., etc., and then you have to find a way of it, right? Now you understood for a short way, right? So I can say now the acceleration of the pulley, if the acceleration of 2 kilogram is 2A, then the acceleration of pulley is A, then obviously 1 kilogram will be having acceleration A in upward direction, right? Now the solving is in the same as that of the previous condition. Clear? So this steps helps in calculating the acceleration of the pulley, okay, and the body which is connected to it, right? Clear? Talking about another question. So fixed pulley 3, that means 3 kilogram. The string is not straight down. 3 kilogram, right? These two should be in the same plane, huh? Sorry if it doesn't look like a straight plane. Okay. Okay. Fixed pulley, fixed pulley. This is not a fixed pulley, it's a movable pulley. Okay. The the weight will be, I will draw it very low so that you guys can see it. That's 1 kilogram, huh? Clear? Now pause the video, try to solve it by yourself. Okay, now suppose I'm telling you the acceleration A for 3 kilogram. Okay, that is only short trick or a thing which I'm going to give you. Okay, I could have removed there now. Remove acceleration from there. I will write here. Then you can see the full. Let's say this is acceleration. Now this you can see the diagram. Okay. So start from below 1G. Right. Now don't write tension here because the string individually without any problem here you're having in the next two conditions. Pulleys always start from the what? Fixed pulleys because that is easy. So tension outside. Okay, tension outside. Right? Same. See, this string is coming, then it moving like this. Right? Now that tension. So this tension away, tension. So those two tension causes 2T tension here. Clear? Simple. I could have written T here, not below. Sorry. Okay. Right? Now again, so you are having a scenario here, right? So let's say acceleration of the pulley is AP, right? Right. What will be the acceleration of this string? This one, the acceleration will be 0, right? See, this is like this. This is the system for this leg of the movable pulley, and this becomes the second leg of the pulley. If you don't remember we had a pulley, we had two legs now with two masses, right? And this is acceleration A1. Let's say it is A2, and we told acceleration of the pulley will be A1 plus A2 by 2, right? Now this system, this pulley has been inverted. This is that pulley, this one, same, and these two legs are for these two legs, right, which has been extended to here. So I can just talk about these two extended legs, right? Clear? Now I just wrote, right, since the right string, right, is from the fixed support, I can write this acceleration is equal to 0, right? Whereas this string is attached to a weight which is moving downwards with an acceleration A. So here acceleration will be A, here acceleration is 0, right? So I can write acceleration AP is equal to, see, minus AP. Why? See, if these two both are moving with a downward, this acceleration means AP will be moving downward direction, right? So AP is downward means it is minus AP is equal to, now A is equal to minus, now this A minus direction minus A plus 0 by 2, or I can write AP is equal to A by 2, right? Clear? That is, if 3 kilogram is moving with an acceleration A, then 1 kilogram, because the same pulley is connected to 1 kilogram. So what acceleration the pulley is having, the same acceleration the 1 kilogram will be having, right? So 1 kilogram will be moving with A by 2. So better let's make this is 2A. So this becomes what? This is 2A and this becomes A. Just to look, rather than using fraction, it is better to use numericals like this, right? So now I'm going to change, right? Suppose okay, let's remove this one, right? Suppose the acceleration on 3 kilogram is 2A, right? Then the acceleration of 1 kilogram will be A, right? And that is due to acceleration of our pulley is now A. Clear? Right? Now it is easy. We will talk about each kilograms, right? Let's say we'll talk about 1 kilogram. You can write 1G because in the same direction of acceleration, minus 2T is equal to 1A, right? Clear? Now this is for 1 kilogram. Similarly for 3 kilogram, look into your figure, guys. You will be having T is equal to 3 into acceleration, mass into acceleration, which is 2A, that is 6A, right? Now we have to find or solve these two equations. So what should you do? Because here there are 2T, multiply 2 here, so that the second equation now becomes 2T is equal to 12A. Right, now solve these two equations by adding these two guys. That is g, 1g can be written as g is equal to 13a, right, or acceleration is equal to g by 13. What the answer? Right, that is 1 kilogram will be having acceleration a, that is g by 13, and 3 kilogram has double its acceleration, that is 2g by 13. And you can just find the acceleration, tension as 6a, that is 6 into g by 13, that is 6g by 13 is tension in the strings. Clear? Easy. Okay, now we'll do another question. We'll do a lot of questions to understand the basics of it. Even if you listen to the first question and you are not understanding, listen to the next question, it goes on, then you will understand the pattern, right? This is a fixed pulley. Now let's say there is a 2 m. We can stop writing kilogram, right? Let's say there is a movable pulley, right, this, and it is having one string like this, one string connected such that it is this string is connected to this stand. Okay, clear? Right, so there will be tension, right? So let's say this, right, so this is the part of the same string. Okay, let's say another mass is connected here, right? So better m, right? So there will be mg downwards, tension upwards, the same string goes here, so away t, away t. So these 2t contributes for 2t here. Okay, right? Now let's say this mass m is moving down with an acceleration a, right? So we'll take for this pulley, that is, let's say acceleration of pulley is ap, right? So this is a, this acceleration is a, then since it is a continuation or coming from this portion, this will be acceleration in this direction, right? Clear? Right, whereas what is the acceleration here? 0, because it is connected here, right? It is fixed there. So this string is not having acceleration. This string will be moving down, trying to moving down, right? So IAP is equal to, here there is no up and down, right? In this two condition, there is no up and down horizontal. So I can just write a plus 0 divided by 2 or a by 2, right? That is, this pulley will be having acceleration how much? A by 2. That is, if the pulley is moving up or in this direction in a by 2, then 2m will be also moving in the acceleration a by 2, right? Now suppose I change this and all, if that is 2 mass will be having half the acceleration as that of mass m. So in place of a, if I write it as 2a, then in here I can just write it as a. That is, pulley as well as the body 2m will be moving towards the right in the acceleration with the acceleration of a. Clear? Now let's take 2m separately, right? When I just consider 2m, there is a 2t in this direction, tension, acceleration here, right? So I can just write 2t is equal to 2ma, that is mass into acceleration. That is our first equation, right? Let's talk about the mass capital M. There is a tension upwards, 2a acceleration downwards, right? And there is mg downwards. Acceleration direction is taken as positive, hence mg minus t is equal to 2a. This is your second equation, right? Now in order to solve these two equations, I have to multiply this equation with 2. So 2mg minus 2t is equal to 4a. That is equation number 3. Now equation 1 and 3, if I add, I will get 2mg is equal to, there is 2ma now, and there is, okay, oh, in place, sorry, I'm extremely sorry, I just wrote acceleration here now. Acceleration into mass is there, so acceleration into mass is, right, mass into acceleration, there is 2ma, so here 4 am or ma, right? So here will be 2 plus, now if you add first and the third equation, 6 ma, right? I can cancel right? I can write this 2 and this as 3, or I can write a is equal to g by 3, right? Now that means 2m mass will be moving with an acceleration g by 3, that is a, and m mass double the acceleration, that is 2g by 3, right? And the tension I can write is what? T is equal to ma, that is 2t is equal to ma, 2 can be cancelled, so that is equal to m into 2g by 3. Clear? That is the tension of the string. This is how you are supposed to find the answer, right? Clear? Right? Now this and all are not tough if you understand again the logic of the problem, right?